Hello everybody, what's up? Hope everybody's doing well today. J7409 here, or astronomy, and I want to talk to you a little bit today about stars. How big is the largest known star compared to planets? Stars will always be the overall group winners in terms of super size, and I've got some really cool pics I'm going to show you here in a minute. When you look at the night sky on a clear night, and away from city lights, you will see that there are stars of varying sizes and brightness. Now, some of which are sure to outsize even our own sun. Now, what your observations will not tell you is just how much bigger than the sun some recently discovered stars are. However, before we can truly appreciate the size of other stars in the universe, we need to have an understanding of the staggering scale at which our own nearest star stands within the solar system. Now, check this out. Check it out. Look there. There's Earth right there. There's the Sun. There's Jupiter, Saturn, Mercury, Venus, all the other little planets around there. Look at that. Can you imagine? Check that out. It seems the sun, despite its actual size, can appear small in our sky, but it's a massive 150 million km, or of course 93 million miles away. Now, storms have been forming for billions of years. Countless have died. Many exist as we speak, and no doubt millions are yet to be born in the future. But one of the key factors that a star's size will depend on is what stage of its life it is at. Converting hydrogen into helium and releasing energy as a byproduct is what stars do for the majority of their lives. Now, the phase is called a star's main sequence, from its childhood right up until middle age, okay? But the final stages of a star's life are different. Most stars will radically change in size and appearance and suddenly swell, getting larger in old age. Now, the average size star becomes a bloated red giant. Larger still stars in their final life phases expand to become red supergiants. Now, I'm going to show you a pic here. You can pick the old ones out from the new ones really easy here in this particular shot. See the red ones? Well, they're the old ones. The blue ones are the newer ones and the hot ones. These are the ones that are on their way out. The blue ones are the ones that are growing on their way in to maturity. Now, so the biggest stars currently in the universe are those who were born big but have also matured and reached old age. However, beyond a supergiant star, there is bigger still. That's right. Compared to the numerous other stars in the night sky, these special stars, known as supergiants, are few in number and very far away. This is why what we know about them and what they will do in the future remains limited, as astronomers get few opportunities to study them. So, what do we know about hypergiants? Just like all the other stars in the universe, these huge stars can vary in size and color. Of the very few discovered hypergiants, they fall into three main color categories: blue, yellow, and red. A couple of characteristics can be recognized in all of them, however. Firstly, they are all very hot, at least within their cores, and are very luminous. Astrophysics agree that the bigger the star's mass, the greater the pressure and the temperature within the core. Now, also, I'm going to tell you something else. It seems that, as the stars are beginning to start burning up in vast quantities, they're burning up hydrogen fuel at such a great rate. They're unstable and violent, and well, they just spew out much of their contents into space and into the stellar winds. And the quantity of star material fired into space in a hypergiant solar wind can actually be so great that it can obscure its true shape when observed from hundreds of light years away. Hypergiants also tend to have extended atmospheres, reaching far into space, making measuring these space monsters to a high degree of accuracy really difficult, folks. The most massive star actually means something quite different from the term largest star. If stars could be placed on some kind of stellar weighing pan, the most massive star will be the heaviest measured, while the largest will be the widest in kilometers or miles. So there's a difference there, huh? Always something to learn about, huh? Now, firstly, what is the most massive star? Well, I'm going to show you a picture of it. There it is. That's the most massive star. The answer is R136A1. This star can be seen as the biggest and brightest star in the center of a large cluster of stars in the Triangulum Nebula. Now, it's in the constellation of Dorado. The cosmic kingpin weighs in at an impressive 265 solar masses. In other words, it has 265 times the amount of star stuff inside it than our sun. Now, this was only discovered in 2010, and when it was discovered, this blue hypergiant star broke then accepted laws of science. Its calculated mass was twice that astronomers thought was possible. They didn't even think it was possible for it to be this, okay? The star also holds another significant record as the heaviest star. The added weight means its contents must be under even greater pressure at its core. That excess energy overflow from the nuclear fusion reaction within R136A1 means that more energy pours out from it into outer space in the form of heat and light than from any other known star. In other words, this star you're looking at, R136A1, is the most luminous star known. So there you have it. Now, secondly, what is the largest known star in outer space in terms of volume? Well, I'll show you that one. It's kind of pretty there, huh? The answer is VY Canis Majoris. It's a red hypergiant which can be found in the constellation of Canis Major, the big dog. Now, this super colossus 30 to 40 times as heavy as our sun. That's right, it's 30 to 40 times heavy as our sun. Check it out. It squeezes to the red corner of the cosmos with its staggering girth of 1,800 to 2,100 solar radii. Now, this is around 1.5 billion km, 930 million miles. Were the star to replace the sun at our solar system center, its surface would lie not far short of the orbit Saturn. That is how big this star is. Kind of hard to believe, isn't it, folks? It's like, you know, when we have a sunny day, we look up at the sun and we think, wow, that's big. It lights up everything. Well, this sucker is a whole lot bigger than the sun. Okay? It's a whole, if it were to take the place of our sun, it wouldn't be up in the sky. It would not be too far from Saturn. How about that? Now, I want to show you this right quick. I thought it was really interesting. It seems that star types from left to right, this is a good comparison for you. Okay? Right there is a red dwarf. There's a red dwarf. There's the sun, of course. And this one right here is R136A1, the blue dwarf hypergiant. Now, where the star sizes are measured by radius from center to surface, and where solar radius is equal to that of our sun. Okay? So look in comparison of everything. This star is much bigger than the sun. Much, much bigger than the sun. It's amazing, just amazing. But to sum it all up, it's just like so many other aspects of the life of hypergiants, their inevitable deaths remain shrouded in mystery. While some astronomers think VY Canis Majoris' demise will be within the next 100,000 years. In other words, if it may have already lost half of its total mass, and think it could be sooner. Two facts are clear, however, though. As the story of the universe generally rewards us with a supernova every 50 years. Every 50 years, something like just blows up, you might as well say. That's what it does. It goes supernova. And as the largest star currently has a very temperamental personality, we may not be disappointed. So, I thought this was kind of cool. Wanted to share it with you all about stars. Now you know the largest in miles across, and you know the largest, heaviest in weight, and you know we got stars much bigger than our own sun, and you know how much bigger the sun is than Earth. You be safe. You be blessed. Have yourself a great day. Keep your eyes on the sky, and thanks for watching.